Students, welcome to s.mathguru classes. Now our main discussion is Jacobians. How to solve some problems by using Jacobians. Last video, some problems we solved. It was given in last video. So now we consider the remaining problems. Very easy. These are interesting also. The problem given that u equal to x square minus y square, v equal to 2xy. Calculate del xy by del uv, that means Jacobian of xy. So solution, so first we write this one, u equal to given x square minus y square. So if we find del u del x, then we get del x of x square minus y square, and this will be twice x minus 0. This is twice x we get, and del u del y del y x square minus y square we get, and this will be 0 minus twice y. This is minus twice y because we differentiate with respect to y, means x is constant. This is 0 and this is twice y. And since v equal to given 2xy, del v del x del x 2xy. So 2y is constant and del x is 1. This is 2y we get. Del v del y. This is del y 2xy, and this is 2x is constant, del y is 1. This is 2x. We get this one. Now our requirement is first we find the reverse of this. Now del u comma v del x comma y. By definition of Jacobian, we can write this one, del u del x del u del y del v del x del v del y. This is by the definition of Jacobian. We can write this one. So del u del x del u del y del v del x del v del y. So this will be del u del x. We know the value. This is twice x. And del u del y we get minus twice y. Minus twice y we get. Del v del x we get twice y. And this is del v del y twice x. We get this one. Now we expand, if we expand this determinant, this into this minus this into this. So 4x square minus 4y square. So this will be 4x square plus 4y square. 4 common, we get x square plus y square. This is del uv del xy. We get this one. Since we know del uv del xy into del xy del uv, this equal to 1, we can write. This and this cancel, we get 1. But we know the value. This value del uv del xy, we know this value. This is 4 into x square plus y square into del xy del uv equal to 1. This implies this one taking right side, dividing right side. So we get del xy del uv, this equal to 1 by 4 into x square plus y square. So this dividing on right hand side, we get this. So this is our answer. Clear this solution? If clear, then this is our answer. If not clear, then this is our answer. Answer is this one. Very nice solution, very easy, very simple also. Consider another nice problem. If x equal to uv, y equal to u plus v by u minus v, find del uv by del xy, Jacobian of uv with respect to x and y. Now solution is start. X equal to given u comma v, so del x del u, this is del u comma v, and this is v into 1, this one v we get. So del x del v, we get del v uv, this is u into 1, this one u, this. Next y equal to u plus v by u minus v. First we differentiate with respect to u partially, then del u plus v by u minus v, we get this. This is our division rule, quotient rule. Then denominator whole square, denominator del u numerator minus numerator del u denominator, this one, and this is denominator whole square u minus v, this is 1 plus 0, del u is 1 and this is 0, minus u plus v, this is 1 minus 0, del u 1, del u 0. So we get u minus v whole square, u minus v minus u minus v. So we get, if we remove the bracket, this is minus, then u cancel, minus 2v by u minus v whole square, this is del y del u, we get this. Next we have to find del y del v, this del y del v. So this will be del v, and y means u plus v by u minus v, and again using quotient rule, u minus v whole square, u minus v del v, u plus v minus u plus v del v, u minus v, and this will be u minus v whole square, u minus v, this is 0 plus 1, u plus v, this one 0 minus 1. So this will be u minus v whole square, u minus v minus u plus v, this minus plus u plus v. Then v cancel, we get twice u minus v whole square. So this is del y del v, we get this one. So del y del u is minus twice v by u minus v whole square, and del y del v is twice u by this. Now our requirement, this one, first we find reverse of this. Now del x comma y del u comma v, by definition of Jacobian, we get del x del u del x del v del y del u del y del v, and this will be del x del u. Del x del u means v, and this is u, and del y del u, this is minus twice v by u minus v whole square, and del y del v, this is twice u minus v whole square. We get this equal to, by we expand this determinant, this into this minus this into this, so we get this into this, we get twice uv by u minus v whole square minus, and this equal to this is minus, and that minus plus twice uv by u minus v whole square, and if we taking LCM, u minus v whole square and twice uv 4 uv, so we get this is del xy del uv, we get this our answer. But actually requirement del uv by del xy, this our requirement. Now since del xy del uv into del uv del xy, this equal to 1. If we cancelling this, we get 1. And we know this value, this is 4 uv by u minus v whole square into del uv by del xy equal to 1. And we divide this one on right hand side, then we get del uv del xy equal to u minus v whole square by 4 uv, and this is our answer. Answer is this one. Very easy solution, very nice solution. Consider another interesting problem. The problem is that if y1 equal to x2 x3 by x1, y2 equal to x3 x1 by y2, y3 equal to x1 x2 by x3 whole x3, then show that the Jacobian of y1 y2 y3 with respect to x1 x2 x3 is 4. Jacobian value is 4. y1 y2 y3 with respect to x1 x2 x3 is 4. We have to show this. Now solution is start. This is very easy solution, very nice solution. y1 equal to x2 x3 by x1 given. First we find del y1 del x. This is del x x2 x3 by x1. Then x2 x3 is constant, this is outside, del x del x1 1 by x1, that this is x2 x3 minus 1 by x1 square, and this one minus x2 x3 by x1 square. We get this. So directly 1 by x1 means minus 1 by x1 whole square. Why we get this result? Because we know this formula ddx of 1 by x to the power n, this is minus n by x to the power n plus 1. Here power is 1, then minus 1 by n, 1 plus 1 2, we write this. And del y1 del x2, again we differentiate this, del y1 del x2, then this is x2 x3 by x1, and at that time we get x3 x1 constant, this is outside, and del x2 is 1, so we get x3 by x1, del y1 by del x3, del x3 and y1 is x2 x3 by x1, and this will be x2 x1 into 1. Del x3, this is 1. So we get x2 by x1. In case of del y1, del x1 we get this, del y1, del x2 is this, and del y1, del x3 is this. Now we find the remaining y2 equal to x3, x1 by x2. So del y2 del x1, then x3, x2 is constant, or first we write this del x1, x3, x1 by x2, and this is x3, x2 is constant, this is outside, and del x1 is 1. So we get x3 by x2. Del y2 del x2, del x2. So del x2, then del x2, and this is x3 by x1 by x2, and x3 x1 by minus x2 whole square. So minus we write here directly. If we using in this way, then we get this formula. So we get minus x3 x1 by x2 square. Del y3 y2 by del x3, del x3, and y2 means x3 x1 by x2, and this is x1 by x2 we get, x1 by x2 we get, x1 by x2. So this is del y2 del x3, we get this one. Now y3 equal to x1 x2 by x3, del y3 del x1, this is del x1 x1 x2 by x3, and this result we get x2 by x3, because del x1 is 1. Del y3 by del x2, del x2 y3, and this value is x1 x2 by x3, and this is we get x1 by x3. This is del x2 1. Now we get del y3 by del x3, del x3 into y3. y3 means x1 x2 by x3, and this result will be minus x1 x2 by x3 whole square. We get all of this. Now our requirement Jacobian of y1, y2, y3 with respect to x1, x2, x3. Now del y1, y2, y3, del x1, x2, x3, this equal to determinant del y1 del x1, del y1 del x2, del y1 del x3, del y2 del x1, del y2 del x2, del y2 del x3, del y3 del x1, del y3 del x2, del y3 del x2. This one we get del x3. This one we get. This is our by definition of Jacobian, we get this one. Now putting the values del y1 del x1, this value is this one, minus x2 x3 by x1 whole square. del y1 del x2. This is x3 by x1. x3 by x1. And del y1 del x3. x2 by x1. So similarly, del y2 del x1. Del y2 del x1, we get x3 by x2. Del y2 del x2, this one, minus x3 x1 by x2 square. And del y2 del x3, x1 by x2, x1 by x2. And the last one, del y3 del x1. Del y3 del x1 is x2 by x3, and this is x1 by x3, and this one minus x1 x2 by x3 whole square. We get this. Now here x1 square, only x1 given. Here also x2 square, but here x2 given. x3 square, x3 square. Now we find x1 square, all of this same denominator. So this will be minus x2 x3 by x1 square, and we multiplying numerator and denominator by x1. Then we get x3 x1 by x1 square. Here multiplying numerator and denominator by x1. Then we get x1 x2 by x1 square. And here we multiplying by x2. Then we get x2 x3 by x2 square minus x3 x1 by x2 square, and multiplying numerator and denominator by x2. Then we get x1 x2 by x2. And here also multiplying numerator and denominator by x3. Then we get x2 x3 by x3 square, x1 x3 by x3 square, and minus x1 x2 by x3 square. We get this. Now from the denominator, first row we get 1 by x1 square common, and here we get 1 by x2 square common, and here also 1 by x3 square common. So we get 1 by x1 square, 1 by x2 square, 1 by x3 square common. We get minus x2 x3, x3 x1, x1 x2, and here we get x2 x3 minus x3 x1, x1 x2, and here x2 x3, x1 x3, x1 x2 minus. We get this. If we taking this denominator common, 1 by x1 square, 1 by x2 square, 1 by x3 square, then we get this. And this is 1 by x1 square, x2 square, x3 square. And from this column, x2 x3 common, and from this x1 x3 common, here x1 x2 common. So again taking common, x2 x3 common, here x3 x1 common, here x1 x2 common. We get minus 1 1 1 1 minus 1 1 1 1 minus 1. We get this. But here we get x1 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 whole square. This and this cancel. x2 x2 whole square. This and this cancel, and this and this cancel. And we expand this, taking minus 1. Then this cancel, this into this. So in lower class method we can write minus 1. Then this cancel, minus 1 1 1 minus 1. We get this. And middle one is minus, this cancel 1 1 1 minus 1, plus 1, this cancel 1 1 minus 1 1. We get this. Now we expand this, minus 1, this into this 1, this minus. That means we get 1 minus 1. Minus 1 minus 1 minus 1. Minus 1 minus 1 plus 1 1 plus 1. This into this minus this into this. So we get this is 0, this is 2, this is 2 and this one 4. So what we get? Finally we get therefore del y1, y2, y3 del x1, x2, x3 this equal to 4. This is our short. Show that the Jacobian of y1, y2, y3 with respect to x1, x2, x3 is 4. These are proof. So dear students, this is very easy solution, very interesting solution. Just you have to know how to differentiate the function and how to expand the determinant. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. And if you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.